We have a new problem here. Add two numbers. So you are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order and each of their nodes contains a single digit. Add the two numbers and return the sum as a linked list. Okay, fair enough. Okay, so let's understand the problem first. Okay, so let's say we have one value here 7 and this is pointing to next node, right? That's how linked list looks like, right? So 7 3, let's say, and it goes to another one, that is, let's say 1, and this is null. Okay, or null. And we have another one that is, let's say, 2, and similarly it points to another 5, and this points to 9, let's say. Now when you add these two, it would be this, right? This is how. Okay, so if you'll see the examples here, if you will see the example, if you will see here, you are adding 2 4 3 5 6 4, it becomes 7 0 8. That means 5 plus 2 7, then 6 4 2, that is 10. That we 0 stays here, 1 carry forwards to last stage. So here it becomes 4 1 5 5 3 8, right? So this is how it works. So for, if you will take the example 2 4 3, so 2 4 3 is something like this: 2 4 3. This is your first node, the second node, third node, then next one is 5 6 4 5 6 4, and the result should be 7. Then out of this 10, this will stay, this will go to next level. Here 7 plus this one, that becomes 8. That means your output should be 7 0 8. Okay, so this is how it is. Okay, 7 0 8, right? So let's first write in a simple while loop, then we'll optimize it and use recursion for optimization, right? So the better way is recursion, but let's try with a while loop first for simplicity. So first let's take a carry. So this is we are going to carry forward, right? Then we will need let's say one new value, right? New value equals to 0. Then let's say let next node equals to initially null. That is a list, it is linked list, so we assign it null initially. Then let's say temp array. Okay, we are taking an array here. Okay, now we'll write a while. Okay, so when your first one, that one is L1, okay, you have L1, then or you have L2, or you have carry. So we'll till that time we will add it. So basically what we're going to do is we are going to take first node and then see, okay, if the node is not empty or second node is not empty, or we have anything in carry. Okay, that means any carry forward number is coming. Okay, so if we'll understand that here, let's understand a little bit of this logic. So as we have 2 4 3, okay, so this is one node, this is one node, and this is another, right? So if we'll see this, if I'll put as a node, then node dot val will be this value, and node dot next will be these two values, right? In the next step, okay, in the next step, node dot val will be this value, and node dot next will be this value, right? Similarly, at the end, node dot val will be this value, and node dot next will be null, right? Nothing, null, right? So this is how your node is presented here, right? So let's go back to our code. So here, as here we are adding these two if you see the linked list, we are adding 2 with 5, and that becomes 7 4 6 10. So one is getting carried forwarded, right? So if carry forward at the end also will stay there, right? In that condition also we need to satisfy these three conditions. If any one of it is there, then we'll do our operation. So let's see. Then our new val would be your L1 dot val plus L2 dot val plus carry, right? So this is your total. That means your carry forward, if there is anything carry forwarded, then these two like this, right? So this is simple, right? Now the problem is if L1 is not there, that means if you have three nodes in first linked list and 5 nodes in second linked list, or vice versa, there is a chance. So let's put this operator so that if it is null, it would be considered, right? Then here one more thing, if it is not there, if undefined, in that case we will take 0, okay, as we are doing a mathematical operation. Okay, now this is fine. Okay, next step is we need to find out the carry. So let's see, carry equals to math dot floor of, so we'll divide the carry with 10, right? So here if you see 6 4 10, so 10 out of 10 we are putting 0, right? So we are taking carry forward 1, right? So let's do that. So your new val which you have calculated now, is it greater than 10? If it is greater than 10, let's do this, then you will get the value which will be carry forward, right? So next is like the temp array to store the new value. Temp arr dot, here I do unzipped, I'm not doing push. Push will put the new value at the end, right? I'm doing unzipped, that means from starting we'll enter the data, okay, so that it will be in correct sequence. So here we're going to put need new val, okay. So now this is done. Now okay, so now what we'll do is we'll update the nodes. L1 equals to L1 dot next, and L2 equals to L2 dot next. So we are shifting, right? As it may be null, so we are giving a question mark here, so that we'll check whether it is not. If it is null, we'll not calculate it. So basically, we are shifting this way. Okay, we are checking whether this is there, this is there, this is there. Okay, we are updating the current value. So now we will take the array which you have already filled, right? So let's take that array, temp arr dot, here I'll be using for each of item, then here we can put the next node which we are going to return, okay, or you can put here result list, okay. The result list is equals to new, we'll call the function which is given to us list node, right? List node, here we will give each value, okay, but here carefully we'll keep remainder because we have taken this, right? We are going to get keep the remainder and take the quotient to the carry forward, right? Remainder, then okay. So now this is the value which we are going to return, res list. Now let's run it. Okay, it is passing, taking fair amount of time. Let's see it. See its performance, 74.25%. okay, fair enough, fair percentage, right? 74 point. So let's use recursion and see. This is big of n solution, okay, because we have two loops but they are parallelly running, right? So n plus n, that is big of 2n, that becomes big of n. So this is our big of n solution, okay. So this will be a big of n solution. Let's keep it aside. Big of n plus n, that becomes big of 2n, which you can say big of n linear, okay. This is linear solution. Let's comment it out and start a recursion method. Okay, so this is fine. Okay, so this is fine. Next is recursion. Same thing we'll do as a same logic, but we'll put in a recursion method. Let's take a recursion function here. Similarly, we'll take let carry equals to 0, okay, and we will take a recursion function const. Let's say iteration equals to, here we will take two values, that is node 1, node 2. So these are the two nodes we have given, right? So here, okay, now let's Similarly, new val equals to 0, then let next node equals to null, and here we'll put a condition, same condition. So here we had given L1, L2 and carry. Here we will give if node 1. Okay, we'll take it reverse way so that it will be less code. If node 1 and node 2 and carry, not carry, right? If any of these things are not present, we will return null. Simple. Okay, if it is present, let's proceed. So new val, will calculate the new val, same logic. New val would be node 1 dot val plus node 2 dot val plus carry. Simple. And here, as we know, we'll check because length may not be same. Okay, so here we'll check here, as it's a numerical operation, we should be having a default value so that it will not give a not a number issue. Okay, so here it will be 0, then simple, right? Now, okay, we have calculated the new value. So here, let's calculate the carry. So carry would be simple, same math dot floor of new val divided by 10. So the quotient will take as a carry forwarded value. Next node equals to, now this next node, which will be in we are doing the recursion, right? So same function will call again, right? So iteration. So as we have this next node, okay, here it is. Okay, next node equals to same iteration function will call, but this time we'll go to next node really here, right? We'll go to next node of it. Okay, we'll reduce it slowly, right, one by one. So here what we'll do is we'll put node 1 question mark dot, that means we are checking if it is not null, then we'll find the next, then node 2 check null, then next. Okay, so this is recursion, means in a one we are reducing one, right? We are visiting to next node, right? Iteration is happening. So next, once this is done, return new, okay, list the function. What is the function name? List node, right? So list node of next, same logic, new val of remainder 10, which will be added, right? 10 next node. Okay, next node, right? So this is going to calculate one by one. It will visit one node, then next node, like that. So we have to call this function as well. So let's put it to return. Okay, call the iteration function with the initial value which was given to us, L1 and L2. Simple, right? So let's run it. Okay, it is taking very less time, 84. Last time, if you remember, it was taking 106. The linked list will be like, let's say this is n, right? And your recursion will run for n times, so that would be big of n, right? So this is, as this is going to run the maximum number of nodes available, it will be relatively having a big of n complexity also, but it is faster than the previous approach because it is having little bit higher big of n plus n, which will be little higher if the comparison to this one. So this will be faster than the other approach we have. So let's, if you can see the time complexity also, which is registered here, is kind of faster than 89.53, right? It is faster than, it is efficient than 89.54 people, right? A percentage of people. So it is, that was 74% something.